Welcome back. Now let us start learning the regression. And let us start with a very basic one, that is the simple linear regression. And the simple linear regression is there in existence for more than 100 years and people have been using it. And as if we are learning here just for the concept, and many of the modern data is so complex that linear regression really does not work out. But why we are learning? Because this is one of the fundamental things almost all the data scientists should be knowing it. And that is why we are learning it. Okay, so let's start. In line 128, we are loading the encoded one, which we have generated up somewhere. So we are loading the encoded one, 128. And we are doing the partition. Partition means we are dividing the data, training data, in 85% train and 15% test. So that is what we are doing, and that will be using the caret library to help us. And what in 131 we got the library, 132 we are saying you divide it in 85% randomly and another 15%. So 132 is giving some random number of some number. This is the sum number. If you see, so some random number. And the test we are taking minus means not this one. So as soon as you say minus, it means this test has become around 15% and train has become 85%. So I'm running line 133. So if you see here, this has been divided. Okay, and if you see the dimension in the 134, so this is what our dimension is all about. We are detaching the caret because we don't need any more. That's okay. And linear regression in R, it is called LM, and this is the way. And this is the formula, MPG tilde dot. It means we want dot means all the column, and it should look the data over here. So fit LM, this is the 139 is the creation of the LM. And if you want to see the summary, I'm just running 140. It is giving us this one. So if you see over here, so there is some kind of coefficient, some standard error, and the t-test, it has done it. So if wherever you see there is a star, those are the confident, it means those are the significant, and those are the significant at the different confidence level. And what is the meaning of confidence level? You have already learned in the statistics part. So if you see that 0 means it is at almost 100%, and this is around 0.001, it means around 0.1%. This is around 1%. This is the 0.5%, and so on. So this is the various significant level, and so overall it looks looking good. Okay. And a few things I would like to explain over here. Something called degree of freedom. Degree of freedom simply say that how much if you fix any one variable, and then how much things it can vary. That is what it means. That is what it means. And there is something called R square. R square is it says that what is the variance it can explain, or how good your model is. So 0.82 means around 82% it has the good. Okay, and adjusted means this is when you try to add any coefficients and all, a few more extra. So for how much it is decreasing, and all, generally it decrease. So this is what 81%. But any one R square is good enough to understand. And this is the statistics, CFA statistics of this model itself. Nothing much to know. And p-value, if it is less than 0.005, it's really good. Otherwise, it will say that it is not able to understand. Okay, this is what the brief understanding of this one. Now let us draw this 142 to 145 we are running together, and this is what it has gives.